Hello there. I hope you're having a good day and are safe out there. Welcome to another video from Codezilla, an open source driven technological enthusiast club. The name is Surya and I'm going to be your today's host. You might have heard about terms like Bitcoin, Ethereum, Ripple, Litecoin. What are all these terms? These are known as cryptocurrencies. These are digital assets designed to work as a medium of exchange. They are basically universal currencies, and all of them work on the technology blockchain. In this video, we're going to talk about blockchain technology. The key takeaway points from here will be: what is a blockchain, why blockchain, how blockchains will be used, applications of blockchain, and mining of cryptocurrencies. Now we'll see what is a blockchain. Formally defining a blockchain, it goes like a suite of distributed ledger technologies that can be programmed to record and track anything of value. Blockchain was first designed by Satoshi Nakamoto, which is a presumed pseudonym for the person or people who designed the original Bitcoin protocol in 2008. Blockchains are widespread and are being hugely used nowadays because blockchain is a digital ledger that lets you keep thousands of strangers honest and consistent. Now let's see why blockchain. To understand this, we need to see the problems blockchain addresses. I'll be sorting out the whole set of problems which blockchain addresses into three parts. Number one, tracking and storage of data, the problem of trust, and the problem of intermediaries. Blockchain is based on the centuries-old ledger method, commonly known as notary, in which we use a book or a record to write over every time and change and store data such as ownership of property, value of a resource. Its storage is prone to danger due to its volatility, centralized nature, and vulnerability to nature. Blockchain addresses this problem by making the whole data decentralized and having separate copies with every node in the chain network. The second problem which blockchain addresses is the problem of trust. During any transaction, we need to place our trust in someone or something apart from the peer-to-peer for its maintenance, which is susceptible for corruption and tampering of data. Blockchain addresses this by creating a cryptographic puzzle and a solution which will be verified by every node in the network for any change or addition of blocks in the chain. The third problem which blockchain addresses is the problem of intermediaries. In our day-to-day life, whenever we make a transaction, we always involve a third person or an intermediary. This can be in the form of a bank or an organization or a particular person who involves and makes the process smoother. We often pay them our time and resources for their services. Blockchain addresses this problem by establishing a peer-to-peer contact and having a complete trust in the system since being cross-verified by every other node in the network, thus saving our time and resources. Now let's see how a blockchain works. Whenever we want to change the data in a blockchain, we cannot override the data, but add a block representing the change, which will from then be perceived. Hence, we can have a time-recorded steps from where, when, and how the data is being changed and can be easily tracked back. Now let's see the process of how a block will be added to the blockchain. Here at the beginning, a transaction is requested. A block that represents the transaction is created. Then this block is sent to every other node in the network. During this process, a cryptographic puzzle and its solution will be created in correspondence to the contents of the block's hash. Then the nodes in the network solves this puzzle, and by solving this puzzle, I mean the blockchain software and the PC's hardware does all the hard work for them. This process is called proof of work. Here, once solved, the answers will be cross-checked and verified. Then, if every node reports the same contents, then the validity of the block's data is true, and then the block is added to the existing chain, hence completing the transaction. Now let's see with and what the blocks in a blockchain are made of. Here we consider a small blockchain of 3 blocks. As you can see, the first block is called a genesis block. Every block in a blockchain contains the data, a hash, and the information about previous hash. The hash is like a fingerprint for each block. It identifies a block and all of its contents. It's basically like a fingerprint of the block. In the previous hash, we have the information about the previous block. As if you see here, the genesis block doesn't have any information in the previous hash column. But in the second block, we can see the previous hash of the second block is the information of the hash of the first block, thus making a chain of blocks. Now let's see applications of blockchain. Coming to the applications of blockchain, they are virtually limitless, ranging from automotive industry to cybersecurity to energy to insurance, IoT, marketing, music, media to real estate. They are all hugely used in nowadays. First, suppose let us take the example of automotive industry. We can use blockchains here to track truthful and full history of vehicles from pre-production to sale. In the industry of music, we can use blockchains to prevent illegal downloading of music and to provide proper compensation for purchased songs to artists directly. In the case of energy, we can use blockchains to bypass public rates to allow for cheaper and peer-to-peer energy transfer. And also we can use them to create a smart usage metering of energy. I sort out the whole applications of the blockchain in majorly 4 categories, namely value exchange, security, asset registries, and financial. Under value exchange, we get industries like network infrastructure and APIs, digital content, app development, marketplaces, and smart contracts. Under security, we can have authentication and authorization, governance and risk management as such. Asset registries, under them we can have data storage, logistics, gold and diamond, etc. Under financial, we can have currency exchange, private shares, loyalty points, peer-to-peer transports, and such. Now let's talk about the most interesting topic, mining of cryptocurrencies. Well, it's basically the duty of every node in the blockchain to maintain it. By the term maintenance, I mean cross-checking proof of works which needs to be done for every transaction made in the network. All this will be done by the software which will run on the individual PC hardwares. For the hardware done by your system, you will be rewarded. This is called mining. All you need to have is a good hardware setup which can cross-verify more hashes per second with an electric supply. You need to have a wallet linked to your blockchain. For example, I can suggest you NiceHash. To save your bitcoins, then we can use them to convert them into your cash and into your bank account. Thank you for listening. For more details and queries, contact us at the following links.